Dear students, today in this session, we are going to deal with how to solve the problems on hypothesis testing. So, we know all the basic concept we have learned in the class. We know what is meant by sample, what is meant by population, etc., etc., etc. So, the samples are classified into two types. One is large sample, the other one is small sample. If the size is greater than 30, we say it as a large sample. And when the size is less than or equal to 30, we say it is a small sample. So in the first part of the unit, we are going to deal problems on large sample, and then this large sample, we are going to have problems like this. Problems on proportion, problems on mean. So in this proportion, we are going to see problems on single proportion, problems on difference in proportion. Similarly, for the mean, we are going to deal with single mean and difference mean. So let us go into the session and explore the problems.
Procedure. So we know very clearly our H0. So H0 always accept there is no difference between two data. Whatever it is given, it is proportion, sample proportion or population proportion or two difference proportion. So H0 always, for example, you take two proportions, H0 will agree they are same. H1 is called as alternate hypothesis, or people say it as a revolutionary hypothesis, which never agree what H0 says. It always says, okay, there is some difference. Okay, so this is classified into two types. I'll explain you the situation. Okay, if two students are there, we have to compare. So what we can say, H0 will say, there is no difference between student 1 and student 2. But H1 will say, there is a difference between two students. Okay, so if you have a question like situation like, if they ask you, is there any significant difference between two cities or two students or population mean with sample mean, or if they are asking like significance difference, you can answer only one thing. You say no, there is no difference, or there is a difference. So in that case, you cannot say which one is better. For example, here I cannot say S1 is better or S2 is better. I say there is no. For example, I'll take all the students in the class should get 80 marks. This is my target. That's not possible, right? Some student may get 70, some student may get 100, some student may get 0. So my mark, I cannot fix my mark as 80. So then what is the chance? I can say it is not equal to 80. So maybe more than 80 or less than 80 can happen. So in this case, we use this as two-tailed test. Okay. Now, suppose you are buying a machine and using for 1 year. Now, the machine has some fault. So you are going for repairing. So B represents before repairing, A represents after repairing. So in this case, your null hypothesis, okay, what we say, before repairing or after repairing, there is no difference, they are same. But alternate hypothesis, when you go for this situation, after repairing the machine, the performance should be improved. Otherwise, why you go for repairing or re-oiling it, okay? Can you get the point? So after repairing, it should have to perform well, it is obvious. So in this situation, I cannot use two-tailed test. It is going to be single-tailed test. I say larger. I'll tell you another situation. Suppose patients are using insulin. So before using insulin, you check the sugar patient's blood level. After using insulin, you have to check the blood level. So H0 as usual, it says they are same. So in this situation, I cannot say H1 is after using insulin, the patient's sugar level can increase because they are coming for what? Decreasing the sugar. So before testing and after testing with insulin, the sugar level should go down. So in this situation, I cannot use greater than, I should use less than. Okay, now it comes in single tail test. So there is a situation I can see two tail test as well as one tail test. How you understand, you can see the word, there is no significant difference. Or when you go for single tail test, they will ask which one is better than this or better than that. Okay, you have to check the question clearly and you have to fix this, guys. Done. So the next one is step 3. So significance level. So default it will be given 1% or 5% in the question. If it is not given, always we have to choose alpha as 5%. Okay. Then from the table value one tail or two tail, we are going to catch the data. Then we have to use the appropriate formula according to the type 1 to 4, and denominator represents the standard error. So as usual, I said we are not going to use here left tail or right tail. I use only one tail test, or it is going to be two tail test. So for this situation, whenever I solve the problem, I always used to take modulus to avoid negative value. I need only positive value. So once you find mod Z, you can find Z alpha, that is tabulated value, and if my modulus value is lesser, H naught is accepted. As I said, the clue, you have less money, you will be accepted everywhere in a safety way. If you have more money, you are in a danger zone. Okay, you should be cautious and careful. H naught is rejected. Okay, so you will reject many places to travel for safety purpose. Okay, this is no mathematics involved in it, for your understanding. If you have less money, you can travel and enjoy. You can accept H naught anywhere like this. You can remember. If you have more money, you cannot travel all the places. So you have to reject some places due to safety reasons. Something like this you remember. Okay, that's not the unique way. You can remember in your own way. Okay, guys. So when the sample is going to be more than 30, then it is going to be large sample. When the size is going to be less than or equal to 30, then I can say this as a small sample. That's why we use like this. It is small and large sample n greater than 30. So this is what we are going to deal, guys. Okay, let us go into the problem. So tabulated value, as I said, two tail means 1.96, one tail means 1.645. For alpha equal to 1%, 2.58, 2.33. You can easily remember it. So as I said, type 1. So type 1 is going to deal with sample proportion and population proportion. So your formula is going to be difference between sample proportion and population proportion, where P is going to be given in the question, and from P I can easily calculate Q. Okay, let us see. N is the size of the sample, P is small, that is sample proportion, capital P is population proportion. So once you know P, as usual Q is equal to 1 minus P, because we know from the unit 1, P plus Q is always 1. That's it. Now we have to go for conclusion. Just now I said conclusion is universal for all large samples. So now sometime they will ask you find CI, confidence interval or confidence limit or confidence level at 95%. So here we have to take always two tail test. So 95% confidence limit means 5% is my level of significance. So alpha 5% two-tailed test means Z alpha 1.96. So if they say the same thing, like 99% confidence interval, in this situation, level of significance is 1%. So I have to take Z alpha as 2.58. That's what we are mentioning. This is MCQ, guys. You see, they will ask 95% confidence interval. The formula is P plus, okay, so since it is a lower limit, we'll take minus Z alpha PQ by N, P Z alpha PQ by N. That's it. It is going to be very simple. So now Z alpha value can be replaced here. Okay. What is your Z alpha value? If it is 5%, I can use 1.96. If it is 1%, I can use 2.58. You can see the table now. That's it, guys. So capital P, small p, everything is same. In the case for finding Q, okay. So either if you take, this is the thing, or if you take like this, both are same. Okay. We have the same concept. You can find small q and capital Q. Okay, let us go into the problem, guys. So as I said, we should be like Google. We have to do machine learning. One by one, we have to scan and we have to get the data and we have to analyze. N equal to 1000 first data. Okay, good. It is greater than 30. Large sample. So we don't have any issue to use Z formula. It is large sample. So we see now N is 1000 greater than 30. It is a large sample. Out of 1000 people, 540 people out of 1000 are vegetarian. Okay, vegetarian. Okay, that means they are giving us the clue. Out of 1000 people, 540 people are vegetarian. It is the proportion or sample proportion. Okay, it's going to be 0.54. That's the clue given to us. Very nice. What they say, can we say both the habits of eating are equally popular? That means vegetarian and non-vegetarian. So equally popular. So city represent the population, 1000 people represent the sample. So my population proportion, in the question it is very clearly given what it is, capital P, but they are giving 50-50, vegetarian or 50-50. So my capital P is going to be 0.5. That's what I'm trying to say. Done. So now H naught. What they're asking, can it be the eating habit or same or not? So either you can write in wordings, textual form, or you can write in mathematical form. So first H naught always agree. Okay. The population proportion are equally likely vegetarian and non-vegetarian are 50%. H1 will come for 5. No. It cannot be 50%, but I don't know what is the, which one is bigger. Okay, because they are clearly mentioned, can we say both habits are equally popular? So if they are equally popular, then it is H0. We say they are not equally popular. For this question I can answer. They are equally popular. They are not equally popular. So equal to, not equal to. That's your H0 and H1 guys. So you can either say in wordings or in mathematical form. So it is two-tailed test. And alpha is given as 1%. Two-tailed test, immediately table value is 2.58. I can go like this. So now we have to go for test statistics. Small p is 0.54. Capital P is 0.5. Okay, capital P is 0.5. Then Q is also 0.5. So Z is equal to P minus P divided by PQ by N. Let us substitute this, guys. So take your calculator and solve the values. So my value is going to be 2.529. So since my table value is 2 decimal, you can even use 2 decimal, nothing wrong in it, or 3 decimal. So 2.529. Always I said do the modulus. So now better you can write like this, 2.529. Z alpha value we have already calculated, 2.58. So very important, write Z alpha and modulus Z and compare it. Now this is bigger, right? This is 529, this is 58. So that's why better to have 3 or 4 digit round up, so you will avoid the error. Okay. Suppose you are rounding this into 2.53, that is also okay. So now my calculated value is lesser than alpha value. So H not accepted. Guys, don't simply write H not accepted. Okay. Sometimes what people are giving 1 mark for final conclusion. So what's your final conclusion? So from the hypothesis, I say the population proportion of vegetarian eating and non-vegetarian eating are same. Habits of vegetarian eating and non-vegetarian eating are same. That's what we are going to say. Hope you understand, students. So this is what we are doing. Done, guys. So if you understand this, guys, problem over. Now the next problem, I am not going to do all these things. So our aim is to fix whether the H0 and H1 are one tail or two tail. Let us see. It is a little different kind of problem. So 400%. Okay, good. N equal to 400. Large circle. Done. Next one. 120 people are female. So females are 120. Then that means male or what? 400 minus 120. Okay. So use your calculator. I know the answer, but for practice I'm just displaying the calculator. Okay, always use the calculator. Don't do any manual errors. So it is going to be 280. So now males are 280. Can we say that males and females are in the ratio 5:3? Okay, good. So now they have given something different. See here. So N equal to 400. So proportion of male you can take or proportion of female you can take. Since I'm a male, I'm taking proportion for male. So male person we found 280, female 120 and total 400. So out of 400 people, 280 people are male. Okay. So nothing wrong. You can even take female. Then you have to calculate for female. That's it. So N is known, small p is known. How to find capital P, guys? So it is given in ratio. Don't worry. So ratio means denominator, always we have to add the ratio. So I am dealing with men. So males are 5, women are 3. So my population proportion is 5/8. This is the case of male. Suppose you are taking female. So my small p is going to be 120/400 and capital P is going to be 3/5 plus 3. Both are same, guys. Okay. Whatever you like, you can just take. It is not a big deal. You can just do whatever you like. That's it, guys. So now you see capital P and small p we can found out. So my H naught is going to be, I'm going to say the female and male proportion are same. So capital P is going to be 5 by 8. H1 will say capital P is not equal to 5 by 8. Okay, that's what we are going to see, whether they are equal or unequal. Okay, let us see the problem. Here, level of significance is 5%. So Z alpha is going to be 1.96. Sorry for interruption, guys. So alpha is equal to 5%. Z alpha is equal to 1.96. So now we'll go into the slides. Yeah. So once you substitute, you found modulus Z value is 3.09 at 5% level, two tail 1.96. So it is greater than Z alpha. So I have to reject H naught. So that means the population proportion, we say 5 out of 8 are men is not true. So it may be less than 5 or more than 5. I don't know. Okay, guys. So hope you understand. Similarly, you can see a lot of problems here. Okay, I'll explain you. A die is thrown 9,000 times. You have to get 5 or 6. Okay. So probability of getting 5 when you throw a die is 1 by 6. Probability of getting 6 is 1 by 6. Probability of getting 5 or 6. So there is nothing common between 5 and 6. So P of A, this is nothing but P of 5 union 6 is going to be P of 5, P of 6 minus P of 5 intersection 6. So there is nothing common between 5 and 6. So I can say P of 5 or 6 is 1 by 6 plus 1 by 6, that is 2 by 3. Okay, done. So this is going to be my small p. So now you see, this is going to be my capital P. Okay, this is universal. Okay, the probability of getting 5 or 6. See the question, out of 900 times, I am getting probability of 5 or 6 with 3,240 times. So this is going to be my small p. Now I am going to check whether they are biased or unbiased. Means what? The game is going very proper. Biased means there is a cheating. So let me do it now clearly. So n equal to 9,000 times I throw a die. When I throw a die, probability of getting 5 or 6 is 3,240 times out of 9,000. But universal probability for getting 5 or 6, just now we discussed, is 2 by 3. 1 by 6 plus 1 by 6. 2 by 6, it is 1 by 6 plus 1 by 6. 2 by 6, it is 1 by 3. Okay, this is going to be 1 by 3. So n is known, capital P is known, small p is known. They are saying whether it is unbiased or not. If it is biased, there might be cheating. My capital P should be 1 by 3. That is my H naught. We say it is biased. H naught say no, there is a cheating. This cannot be equal to 1 by 3. Let us see what happens. You see all the data are given. Alpha is not given, so I am choosing 5%. Let us go into the problem, guys. Substitute the values. So modulus of Z is 5.37. Z alpha is 1.96. So we have to reject it because the calculated value is more. Okay, the calculated value is more. I have to reject the data. So that means I can say there is a cheating happening in this problem. So the die is biased. You have to write the wordings at the end. That's it, guys. Hope you understand the similar kind of problems you can see by yourself. What is happening? Let us go into the next slide. So just now we see two-tailed test. We see some examples for one-tailed test, guys. Let us go into the problem. A manufacturing company claims 95% of the supplied products meets the specification. Out of 200 samples, first we have to deal with sample, okay? Okay, 200 samples are there. So 200 means it's a large sample. Out of 200 sample, 18 are defective. Okay, they are given defective thing. But we are speaking here about what? 95% good product. So defect is 18. So my question is speaking with good products. So good product is what? 200 minus 18. So it is going to be 182. Okay. So now my small p. 182 products are good when I buy 200 products. This is my proportion. Okay. But company says they are giving 95% of good products. So capital P is going to be 0.95. But when I do this, what I get, you can always, I said, use calculator better. Don't do assumption. You can check here. So 0.91. Oh my God. When I buy 200 products, my good products are 91%. But the company is saying what? 95%. In this case, I get angry on the company. Okay. So what I am going to do now, P represent my products. That is 91% I get. But company says 95. So I am getting lesser data. My good products are 91. So obviously I will say the company is not producing 95% or more than 95% good products. I'll fight for it. Okay. So what I do, H0 will say the company is saying that their specification is 0.95. But what I say, because I am affected, my proportion is less. I say nonsense. This company is not giving 95%. Their good products supplied meet the specification less than 95 because I have affected by the company with my samples. Now we cannot say this is correct. Okay, my sample maybe have more defective. Maybe some other guy is buying the same 200 sample, he can have one or two defective also. So let us go into the hypothesis testing. Let us check whether my statement is correct or not. Whether I'm saying the specification is bad, company is saying it is meeting the quality of the specification. Let us check this, guys. So this is going to be one-tailed test. So alpha 5%. One-tailed test means, do you remember? Two-tail means 1.96. One-tail means 1.645 Z alpha. That's it, guys. This is the important thing. Fixing H0 and H1. After this, problem is simple. You can just do like this. So here you see modulus of Z should be 2.597. You should not go for negative values. Okay. So my mod Z is 2.597 and calculated value is this and table value is 1.645. Okay, that means what I see, I have to reject H0. Right? So H0 is rejected. So what I am claiming is correct. The company products may need not be meeting 95% perfection level. So they are cheating me. Okay, so I now have to say the company does not meet the requirements. So write something like this, okay? In your own words, the final decision. Done, guys. So now you understand the difference between one tail and two tail. Okay, let us see one more question for clarity. So in the previous question, we are dealing with left tail test. Okay. So I said don't go for left or right tail. Okay, because it is good products. Now in the next question, we are going to deal with defective. So in a low-cost toy production system, molding, the error standards are 1% defective. Okay, very good. Company is saying there is 1% defective. 80 samples. So n equal to 80 greater than 30, done. Okay, so now 1% defective was there. So out of 80 toys, I am getting one toy is defective. That is 1 by 80. So I am getting small p is equal to 0.0125. But company claims capital P, like their company products are 1% defective. I am getting 1.25% defective. So now what I do, I have to fight. Let us see. My data is small p is 0.0125, capital P is 0.01. So what I do, I'll take the null hypothesis, okay, the production, but I am getting more defective. So now in this case, I cannot say the company is less defective. Now in this case, for H1, I have to say the company choice of the machine is giving more defective. Okay, in the previous case, when you go for profit, we get the other opposite sign. We use this. So according to the situation, read the question and clearly use it. So this is what I'm going to claim. They are saying 1% defective, but from my sample, I feel it should be more than 1% defective. Done. So alpha is 5%. So one tail test, because it is greater than. So immediately I can write 1.645. After this, nothing, guys. Just substitute the value. So it is negative. I'll take mod Z is equal to 0.227. Z alpha is equal to 1.645. So mod Z is less than Z alpha, except H naught. So what we are going to say, my error is 0.0125, that is 1.25%. Company say it is 1%, so it is very meager error. Maybe 1 out of 80 samples are defective in my problem. So what the hypothesis suggesting is, it's same. It's not a big thing. Maybe something have happened. So you have to say H0 is correct. Whatever the company specification they say, they are correct.